Hey everyone, my name is Carrie, and today I'll be doing a video segment for exam number 2, practice exam D, problem number 18. So please pause the video and take a moment to just read through the problem and process what we're trying to solve for. So now that we have read through the problem, we can create a visual. Visuals are always great since word problems are very complicated and they give us a lot of information, so it helps to draw a visual. So I've created an animation for you guys, and this animation would just demonstrate what is kind of going on and what the word problem is asking for. So it's giving us that a sample of 30.0 gram of copper is initially heated at a temperature of 245.0 degrees Celsius. It is then placed in 150.0 grams of water, and this water has an initial temperature of 35.0 degrees Celsius. And what we're trying to find is the final temperature of both water and copper. And in this case, the final temperature of water and copper is the same. So now that we've created a visual and we know what's going on, we know what we're looking for, it's always great to write down our information in a table to help us out, just figure everything out and organize our information. So we're given that copper has a mass of 30.0 grams, initial temperature of 245.0 degrees Celsius, and specific heat capacity of 0.375 joules per grams degrees Celsius. We're also given that water has a mass of 150.0 grams, initial temperature of 35.0 degrees Celsius, and specific heat capacity of 4.184 joules per grams degrees Celsius. You're probably thinking to yourself, where did I get this information on specific heat capacity for copper and water? Well, if we flip onto the first page of our practice exam, it's given there, so we can definitely use it for this problem. In equations that we'll need to know beforehand and we worked with before is Q of copper equals negative Q of water. Q of copper is just the mass of copper times specific heat capacity of copper times the change in temperature of copper, which is equal to the negative Q of water. A negative Q of water is just negative mass of water times specific heat capacity of water and the change of temperature in water. And again, just as a reminder, the delta T, or change in temperature, is just equal to the final temperature minus the initial temperature. And what we're solving for is the final temperature of both copper and water, which is the same. Now that we have our information organized, we can plug it into the equation given in the middle column and solve for T final. This equation is just the equation from the previous slide. Q of copper equals negative Q of water, which is equal to mass of copper times the specific heat capacity of copper times the change of temperature in copper, which is equal to the negative mass of water times specific heat capacity of water times the change in temperature of water. Now it is time to plug in what we know and solve for our unknown. After plugging in everything that we know, this is what our equation looks like. Notice that we wrote out all units and we can solve for this step by step. Step 1. Multiply the mass of copper and the specific heat capacity of copper on the left-hand side, and on the right-hand side, multiply the mass of water times the specific heat capacity of water. Notice that the grams cancel out on both sides, and we're left with the following equation. Step 2. Use the distributive property and multiply through, on the left-hand side, 11.55 joules per degree Celsius, and on the right-hand side, negative 627.6 joules per degree Celsius. After distributing, we are left with the following equation. Notice that on the left-hand side, when we distribute 11.55 joules per degree Celsius, the Celsius cancel out. And on the right-hand side, when we distribute negative 627.6 joules per degree Celsius, the Celsius cancel out. And now we are left with the following equation. Step 3. In order to isolate T final by itself, we must add 2,829.75 joules onto both sides. After doing so, we notice that on the left-hand side, this number cancels out. And we are left with the following equation. Step 5. Add 627.6 joules per degree Celsius times T final on both sides. When doing this, we notice that this number cancels on the right-hand side, and we're left with the following equation. Step 6. Divide both sides by 639.15 joule per degree Celsius in order to isolate T final by itself. When doing so, we notice that the joules on the right-hand side cancel out, and so does the number 639.15 joule per degree Celsius on the left-hand side also cancels out, and we're left with T final at 38.795 degrees Celsius. And when we look back into our problem, we have to answer our final answer with 3 significant figures, 38.8 degrees Celsius. And our answer is E. After solving for this problem, let's recap on what we learned for our study skills and test-taking skills. What did we learn in this video? Take time to think about the problem first before solving it. Don't just dive into a problem. Really think about it first. Make visuals to better your understanding of a word problem. Word problems are very hard, so if you make a visual, it helps your understanding. Make charts to organize your thoughts and information to help you solve for your unknown. Write out all units. You can see how important it is, how units cancel out, and what units you'll end up with. And last but not least, show all of your work. If you can master all of these test-taking skills, you are on a good start to becoming a future chemist. Good luck to you on your exam, and best of wishes from your PAL leader.